Good day everyone. We are here to discuss about multidimensional scaling. Multidimensional scaling has become more and more popular both multivariate and exploratory data analysis that creates a map displaying the relative positions of a number of objects given only a table of distances between them. This table of distances is known as proximity matrix either directly from experiments or indirectly as a correlation matrix. The multi-part of the name refers to the fact that we are not restricted to constructing maps in one, two, or more dimensions. One of the goals of the MDS analysis is to keep the number of dimensions as small as possible. If more dimensions are required, you may decide that MDS is not appropriate for your data. The input data for MDS is in the form of a distance matrix. Thus, similarity matrix may need to be converted to a distance matrix. Proximity measures quantify how close two objects are. The program accepts three forms of proximity values: dissimilarities, similarities, and correlation. Dissimilarity matrices represent the distance between two objects. On the other hand, similarities represent how close two objects are. As I've said earlier, similarity matrices may need to be converted to a distance matrix. Thus, the formula would be: there are two major groups of methods for deriving proximities: the direct methods and indirect methods. Both direct and indirect methods of deriving proximity data yield the proximity matrix, which serves as an input for MDS programs. In many practical applications, it will be straightforward to ask the participants directly for their judgments of the dissimilarity or similarity of objects. Indirect methods, on the other hand, might be well suited to the investigation of basic perceptual dimensions, or in the case when of the objects under study already exists. In classical scaling, we seek a configuration such that the interpoint distances in the configuration will be approximately equal to the corresponding original distance matrix. We may wish to have a measure of how good the fit is. This would be useful for helping us to judge how many dimensions are necessary to get a good enough fit. In judging how good the fit is, the stress, also known as Kruskal stress, is calculated as replacing original distance matrix by disparities because we are now interested in how close the distances to the disparities. Classical scaling could be described as metrical scaling since, in contrast to non-metrical scaling, the fitted and original distances are expressed in the same metric. In metrical scaling, we assume that original distances can be transformed into Euclidean distances by some other parametric transformation. Next is we are going to perform a multidimensional scaling on SPSS.